Alright, here we're going to talk about complex numbers. What we've looked at so far is we know that if we want the square root of 9, then the square root of 9 is 3 because 3 squared is equal to 9. I am looking for the square root of 16. I know the square root of 16 is 4 because 4 squared equals 16. And if I want to find the square root of 12, that's not a whole number or an integer value, but simplified, there's two 2's underneath there, and so a 2 can come out and a 3 is stuck. Now today we're going to talk about how to deal with negative numbers under the square root. And these came up in section, I think it was 7.1. But what we did then is we just stopped and said, well, these aren't real numbers. Okay, because when I square a positive 3, I get 9, and when I square a negative 3, I also get 9. But there's not a real number that I can square to get negative 9, or negative 16, or negative 12. So what we're going to do is make a definition. We're going to say, let's let I, lowercase I, be the number, so that I squared is equal to negative 1. Now, I is not a variable. Its value doesn't change. Okay, I is the number, so that I squared is negative 1. That's also a definition, so it's nothing we have to prove either. If I squared is negative 1, then that means we can think about I as being the square root of negative 1. So, alright, we can also say that if we're trying to simplify the square root of negative n, that's the same thing as I times the square root of positive n. Meaning that negative sign, that negative 1 here, can come out from under the radical as an I, and then the n just stays n. So over here, if we are trying to simplify the square root of negative 9, the negative sign can come out as an I, and then the square root of positive 9, we can keep going and call that 3. With the square root of negative 16, we say, well, I can call that I times the square root of positive 16, and the square root of 16 is 4, so we can write that as 4i. Square root of negative 12 can be written as I times the square root of positive 12. And then we know the square root of positive 12 is 2 times the square root of 3, because we took the square root of 2 squared and the square root of 3. So along with the I coming out from under, the 2 gets to join it, and the 3 is stuck underneath. If we go back to section 7.3, I think it was, this is the rule that we used, and we just used that. I'm going to click back right here, and we simplified the square root of 12. We said if I have the square root of the product, I can take the product of the square roots. Okay. Notice the disclaimer here that says if the nth root of a and the nth root of b are real numbers. Okay, then we can break it apart like that, or put them back together. We did that a couple sections ago. So what it means is I have to be careful. If I want to multiply the square root of negative 2 times the square root of negative 3, I can't just put the stuff under the radical back together and call that the square root of 6. Okay, the square root of negative 2 and the square root of negative 3 are not real numbers, which means that rule doesn't apply. But what I can do is simplify each of these radicals, meaning pull the I out from under the radical on the first one, and the I out from under the radical on the second one. Then I can put my pieces together. I times I is I squared. And by definition, maybe I'll just dual page this. By definition, I squared we know is equal to negative 1. And the square root of 2 and the square root of 3, now that those are real numbers, we can put the pieces back together and call that the square root of 6. So first we have to simplify the radicals, and sometimes once I pull that I out from under, that's the best I can do. Square root of 2 doesn't break down anymore, and neither does square root of 3. But once the pieces here are real numbers, then we can put them back together using that rule that we just worked with in a couple sections ago. So I'm going to stop this here, and then we'll come back to actually complex numbers here in just a minute, now that we know how those imaginary guys work.